Okay, this is lesson 5.4, and in this lesson we're going to learn how to factor quadratic expressions that are in the form ax squared plus bx plus c, and we're going to look at the specific cases when a is 1. So all of our quadratics in this lesson are going to start with x squared. The purposes of factoring for this unit is that we're going to switch from a quadratic that's in standard form to a quadratic that's in factored form. Now, why might we be doing this? Well, a couple reasons. In the last unit, we saw it was actually much easier to graph something that's in factored form than it is standard form. For standard form, we'd have to make a table, and we'd really need to kind of know where the vertex is to make that table so we can get both sides or a symmetrical parabola. But if we have factored form tells us something specific about the quadratic. The r and the s tell us the x-intercepts. I just noticed a typo on this handout. It should say x minus r and x minus s, because we actually have the opposite signs. So I'm going to make that correction right now. So how do we switch between forms? Well, first things first, as we saw in the previous lesson, we can do something called common factoring. And the first step for any factoring question is to common factor. Now, since we're only looking at quadratics that start with x squared, we're not going to have a common factor. We're just going to have regular factoring of a trinomial. However, in the next lesson, we're going to look at quadratics that start with ax squared, and we might have a common factor. So it's good to remember that we should always look for a common factor first. If we don't have a common factor, or we've already common factored it out, the next step to factoring is to look for two integers whose product is a times c. And in this case, since a is 1, we're just looking for ones whose product is c and whose sum is b. So what's that mean? Well, in this example, if we were to write ax squared plus bx plus c, a would be 1, because the a is in front of the x squared, b would be 2, and c would be 1. So we'd be looking for numbers that multiply to 1 and add to 2. And if we think for a second what those numbers might be, the numbers that multiply to 1 and add to 2 are 1 and 1. We're looking for two numbers. If we can do this, we can start to factor. Because, well, if we did factor this one would look like x plus 1, x plus 1. And if you look, the two numbers that multiply to 1 and add to 2 are 1 and 1. That's what completes the brackets. That's our r and our s. So let's try a couple examples. We're going to start with x squared plus 7x plus 10. And to factor this one, since it's x squared first term, we get to go right to brackets, right to our factors, and our factors are going to start with x and x. And the reason why is because if we were to FOIL this out when we go to check, we can check this by expanding. And when you check, your first step would be x times x, and that would give you the x squared. To check, we FOIL, or we expand, because if I haven't made it clear in the last video, I'm trying to remember if I said it out loud or not, factoring and expanding are opposites. So factor is the opposite, I don't know how to do opposite, of expanding. Factoring undoes expanding, and expanding undoes factoring. It's like multiplying and dividing. When you're, well, let's leave it at that. Factoring undoes expanding. So multiplies to 10 and adds to 7. Those are the numbers we're going to look for. So what multiplies to 10 and adds to 7? Well, to figure this out, we need to look for all of the pairs of numbers that multiply to 10. So 1 and 10 would work. 2 and 5 would work. And you might think that's it, but actually there's two more. -10 and -1, -2 and -5. So the positive pairs and the negative pairs will all multiply to 10. Now one of these pairs is going to add to 7. And if we look at the list and do some mental math, that would be 11. That one's 7. Because 2 plus 5 is 7. So our numbers that are going to work to fill out our factor brackets are 2 and 5. So x plus 2, x plus 5. It doesn't matter which one you write in which bracket. But now, if we FOIL check, we can see that we got it right because, well, we already did the x times x. Then we got x times 5, gives us 5x. 2 times x gives us 2x. And 2 times 5 is 10. And now if we collect our like terms, 5x and 2x makes 7x. So why does this work? Well, when we look for our numbers that multiply to 10, we're looking for the L, or the last part of FOIL. We're looking for the 2 times 5 step. That gives us our 10. When we're looking for what's multiplying to give us, or adding to give us 7, we're looking for this collecting like term step. 5 plus 2 is 7. Where's the 5 plus 2 come from? Well, it comes from the 2 times x and the x times 5 step, the O and I of FOIL. So how come we didn't really consider this first step in FOIL, F? Well, we didn't need to because there's only one pair of things that can multiply to give us x squared, and that's x and x. So that's how we factor. We're looking basically at what could make us do these 4 steps of FOIL. What 4 terms would make us repeat these steps of FOIL to give us this as a result? It's like working backwards. So we're going to try a couple more here. In this example, we've got 16 is our C and negative 10 is our B. So we're looking for numbers that multiply to 16 and add to negative 10. The negative is pretty important. So let's get our scrap paper out to the side here. Multiplies to 10. So we're not using those. Multiplies to 16. Well, 1 and 16 would work. 2 and 8 would work. 4 and 4 would work. But if we add all these, 1 plus 16, well, that's 17. 2 plus 8, that's 10. We want negative 10, so that's pretty close. 4 plus 4 is 8. So none of these work. The negative pairs. Negative 1 and negative 16 would multiply to give us 16 as well. Negative 2 and negative 8. Negative 4 and negative 4. Now, when you're working with one of these ones, if you add and you get the right number but with the opposite sign, it's likely just going to be the 2 numbers with the opposite sign. So negative 2 and negative 8. If we add those, we get negative 10. That's our pair. Negative 2 and negative 8. So to factor this one, we make our 2 brackets. The x squared comes from the x times x step. And to get the other 2 terms, we need negative 2 and negative 8. Negative 2 times negative 8 gives us our 16. Negative 2 plus negative 8 gives us our negative 10 in the middle. And of course, we could check that by factoring, or by expanding. We don't have to, though, because it doesn't ask us to. Let's try C. For C, we're looking for numbers that multiply to negative 6 and add to 5. So this is our first example where we're looking for numbers that multiply to a negative number. So how do we multiply to a negative number? Well, we need one positive and one negative. So we need a positive number and a negative number. So let's start with positive 1 and negative 6. Or we could have negative 1 and positive 6. Or we could have positive 2 and negative 3. Or we could have negative 2 and positive 3. Box that. All of those 4 pairs would multiply to negative 6. But only one of them adds to negative 5. And it's that pair. So those complete our factors. 2 brackets. The x's give us our x squared when we expand. the -1 and the +6 will multiply to -6 and will add to 5. And there we go, we factored again. I'm going to do D and E. The reason I'm doing all the examples in this lesson is because really when we're doing simple trinomials, there's really only 4 sign combinations that we can work with. There's one where we're both positive, there's one where we're both negative, and there's one where B is negative and C is positive, or where B is positive and C is negative. And those are kind of really the only sign options that we can see. But let's try our last one here. So we need numbers that multiply to -12 and add to -1. So what multiplies to -12? Well, we could start with 1 and 12, but one of them has to be negative, so let's try -1. We could also do 1 and -12. We could do -2 and 6, or we could do 2 and -6. Can't see that. And there's actually one more pair. There's 3 and -4, and there's -3 and +4. So one of those pairs will add to -1. Well, it's not that one, it's not that one. That one adds to 4, that one adds to -4. This one adds to, hey, -1. There's our pair, 3 and -4. So x plus 3, x minus 4. And there we have it, factored form. And again, we could check by expanding. Last one. So we need something that multiplies to C, which is 6, and adds to B, which is 4. So I'm going to do this work off to the side here. What multiplies to 6? Well, we've got 1 times 6, and we've got -1 times -6. We've got 2 times 3, and we've got -2 times -3. And that's actually it. So the question is, do any of these pairs add to 4? Well, 1 plus 6 is 7, so that one's wrong. -1 plus -6 would be -7, so that one doesn't work. 2 plus 3 is 5, that doesn't work because we want 4. -2 plus -3, well, that's just going to be -5, that one doesn't work. So what happens now? We've tried all the pairs, none of them work. There's no more integer pairs that would multiply to 6 and add to 4. So this is called not factorable. Or we could say it's prime, which means we can't factor it. All right, that's actually all of our factoring examples. I have one more example in this lesson, and it's an application question. So let's give it a shot. Determine the binomials that represent the length and the width of the rectangle. Then determine the dimensions of the rectangle if x is 12. So we've got the area of this rectangle is x squared plus 16x plus 28. Well, a rectangle has a length and a width, and we know that area is equal to length times width. Now it says that the length and width are binomials. So what's that mean? Well, that means that we have something times something. Something with two terms, binomials. And our area is, well, x squared plus 16x plus 28. So we need to turn this into this. Well, this is just what we've already been doing. This is just factoring. So we need to look for numbers that multiply to 28 and add to 16. Well, what multiplies to 28 and adds to 16? Well, let's take a look. Multiplies to 28. That's 1 and 28, 2 and 14, 3. Does 3 work? No. 4? No. Yes. 4 and 7. 6, 5? Nope, nope, nope. And the negative pairs would work too, but since we're adding to a positive number, it's probably going to be one of these pairs. So let's see which of these adds to 16. That's 29. That one's 16. That's the right pair. So we got 2 and 14. So to get x squared, we go x and x. And to multiply to 28 and add to 16, we use 2 and 14. And there we have it. Now we've factored, so we can call the first bracket our length and the second bracket our width, or vice versa, it doesn't matter. So let's say our length is x plus 2. And it says, tell me the dimensions if x is 12. Well, the length would then be 12 plus 2, which is 14. And the width is x plus 14. If x is 12, 12 plus 14, that's 26. So we got our width and our length. And that's how we use factoring to find lengths and widths of, well, quadratic areas. And that's it for lesson 5.4. Thanks for watching, and I'll see you in 5.5, where we factor trinomials that don't start with x squared.